So welcome to this session on smart connectivity for converged networks. This is our last session today on the technology for business. And I'm very pleased to introduce Mr. Maylaraiah JN, Country Manager for Technology and Marketing Activities at TE Enterprise Networks India. Maylaraiah is a mechanical engineer. He has more than 18 years of experience in designing networks for data centers, campus and premise networks. And he's completed the RCDD certification and PMI. And he's responsible for technology and product management for India and the SAR for TE Enterprise Networks India. May I request, and today he will be speaking on smart connectivity for converged networks. May I request you all to please welcome Mr. Maylaraiah to the stage.
Thank you so much. Good evening. It's been from morning, most of you would have heard a lot of things about data centers, how to really manage it, what's the concerns about IT. Let's touch upon some of the important topics when it comes to the physical layer, how important it is, and then especially when you look at on a converged network solutions. So, when you look at on a converged networks, on a smart connectivity, today's networks are not just about a small building. It's about the whole township. How do you really connect it across? Each of the campus that you look at today has offices, residential blocks, different malls. How do you really look at in terms of the whole solution is? People talk about a smart township coming up. What kind of connectivity do they actually look at in terms of the converged network is something which is critical and important to know about. So with that, let's start off with in terms of when I look at the trend today is all about the converged solution. Whether you talk about data, voice, video, you might have heard about the triple play services. There are also customers who call it as a quadra play, which also includes the wireless within it. So what kind of solutions does these smart cities do look at? There are customers who look at how do I really manage my power tomorrow? Let's say a customer wants within my campus, what's the power that is being metered? What about the management of the water? What about the sewage? How do you build a smart city across? So there are a lot of things that needs to be looked at when you look at in terms of a converged solution is. Now, let me take a small example to start off with a small single building across. When we look at the baseline, everything has to be on an IP. So you have the voice over IP for your telephonic, then you have WAP, you have the security management, the access control, the electronic lock systems, then you have the lighting management. How do I really take care of this for green environment and the HVAC? There's an increased bandwidth requirement, which is actually raising the bar of the cabling platform that you install across within your networks. And today customers looks at in terms of resilience of a crucial of 24/7 on a 365 days. There are more network devices which are actually driving the requirement of the bandwidth is. What kind of solutions that we need to build in then? The wireless coverage needs to be done across the whole capacity. Today capacity is a big constraint. We talk about 3G, we are looking now about 4G on the networks. Now look at in terms of the mobile network that we have. It is not even able to sustain a voice call. We are not able to get the capacity across. If you talk for 5 minutes, the call gets cut, not even 5 minutes sometimes. So we are looking at video going across. Then where's the capacity built in? What kind of infrastructure that we need to build across is something which is a big topic on the convergences. When you have high bandwidth requirements across for an end customer is, look at the load that the DCs has to carry across for these converged solutions. Whether you call it as an central offices in a telecom environment or a data center for an enterprise networks. What kind of capacity that needs to have is something which is needs to be looked at. There's a high bandwidth demand which is forecasted. Video communication is actually going to overtake your video content that we are doing today. So which means the cabling infrastructure that we built up, the pipe has to take care of such high bandwidth requirements. So what kind of solutions that we need to look at then to take care of these impacts are? Today, if you look at in terms of the broadband subscribers, the voice over IP, HD TVs, multimedia networks, online gaming, look at in terms of the exploiting demand of the web-based applications. You have your SAN within your data centers, you have your data centers across. The most important, you might have heard about the FTTX networks. There are a lot of installations that are going on across this country. What kind of infrastructure that we need to build up then to take care of such high demands and plan? Today, any customer who is building across a smart city, the first thing that they ask is all about a large airport, large campuses. I want to build an infrastructure. It should not be disturbed across for the next 15 years, 20 years, 25 years. What kind of infrastructure should I build? I might have anything coming up, new applications tomorrow. How does this infrastructure existing can take care of those applications to drive? What kind of infrastructure should I build across within the whole city? That's something which is the key. Now, the answer for all this is one of the important media which addresses most of the solutions for high bandwidth requirement is the optical fiber cable. I have a small question to you. Now, I'm sure we look at in terms of how much of kilometers of fiber does this country have per man. If you look at, it's about 39 meters of cable that is laid in India per person. If you calculate in terms of, what about China? It's 197 meters of fiber if you calculate at each person that is being used across the country. Look at the USA, it's 907 meters of fiber cable if you start calculating in terms of each person that exists within the country. So, being a billion plus people, the amount of optical fiber that is laid is so less in this country. So that means which is having a high demand across looking at the infrastructure build-up today. If you look at some of the countries, look at German or even close by Dubai, each residences can actually take by default more than 30 Mbps, which gives whether you want it or not. Today we look at around 256 kbps. We talk about 1 MB, 2 Mbps. That even doesn't come when there's a high load in the evenings across. So how do I take care of building a smart city to run different applications across? One of the important things that I took across is something called power budget. When it comes to an optical fiber, understanding power budget is very critical for each one of us. What does this power budget means and why it's so important all about? A power budget is the difference in an optical power between what a transmitter delivers into a fiber and what a receiver would require if the fiber has to operate properly. Let me take an example. If your transmit is around -12 dBm and the receiver sensitivity is around -27, so Tx minus Rx gives you your power budget. Now why is it so critical? What does this mean all about? Let's say as a customer, you are coming out with a new infrastructure, you're building up a facility, you ask your system integrator or the designers or the consultants, I need a backbone now. So the first thing they do is, fantastic, which one shall I give you, a multi-mode or a single mode? Just take it. Nobody even analyzes about a power budget is. What's the power budget across? Why it's becoming so critical for you when you're especially implementing even a small DC, and upcoming is going to become critical. Today a 40 gig or 100 gig is ratified by IEEE. So why is it so important to look at this power budget chart? Let's say for example, today after you have a 40 gig which is ratified, now across on a 40 gig, if you look at in terms of the channel is, what's the maximum channel insertion loss is 1.5 dB. So which means the overall loss which the link you install, it should be less than this so that the fiber can operate properly. Otherwise, it's not going to work. So when you're installing, it is becoming more and more critical that to analyze in terms of the power budget is, what are the losses? What's the connector losses? What's the optical fiber cable loss itself is? So when you're looking at a 10 gig, nobody is much bothered about. So you have a fiber cable which linked across within a DC. You talk about I want a 10 gig, but it has to be compliant to tomorrow's 40 or 100 gig. How it's going to really sustain that? So you need to really look at in terms of analyzing of all this information which is becoming more and more critical. When it's becoming more and more critical for a DC, you can understand in terms of the criticality of building up a network for a smart city. So you need to really analyze in terms of the whole losses that goes through, which can drive your future applications are. So a 40 or 100 gig runs on a parallel transmission. So you will have 4 fiber on the transmit and 4 on the receive. MPO has been the recommended connector for this. If you look at a 100 gig, today you will have 10 on transmit and 10 on the receive. So there is an IEEE committee formed where each fiber could actually drive you for 25 gig across, just using 4 fiber for transmit and 4 on receive for the 100 gig rather than 10 plus 10. So this is just an important on the optical fiber is. So moving on, one of the most important thing when you also need to consider when you are building up a smart city or a smart data center environment within it, something that needs to be considered is all about the bend insensitive fiber. What's this bend insensitive fiber? We have heard an OM3, we have heard an OM4, we have heard a single mode, something a bend insensitive fiber across. So where did it all start off? A bend insensitive fiber started off with a fiber to the home solution. When customers started looking at a converged solution, I need to have the best of the infrastructure to take care of the future applications that comes in. So optical fiber was the media to be considered. So what were the challenges that came through? The challenges was in terms of how do I really maintain the bend radius within an FTTH solution. G657A was the fiber chosen, which is a backward compatible with the existing fibers of the single mode version on a bend insensitive is. It all started off with a residential. If you look at your normal offices, you have large vertical ducts. If an installer says, I want 10 times the bend radius or 20 times, you can manage it. But how do you really manage it at a residence? You don't have vertical ducts to manage across your backbone cables there. You have sharp edges that needs to be covered. So the answer was the bend insensitive fiber across. You look at in terms of the attenuation that could give on a mandrel. On a standard single mode, you got around 11.24 dB. Look at it in terms of the bend insensitive single mode, which gave you just 0.19. Such a kind of difference in terms of your attenuation characteristics on a standard single mode fiber versus a bend insensitive single mode fiber is. Now, customers also started looking at single mode, fine. We go for bend insensitive. Why not multi-mode? Look at each of your data centers. The first, the rack which is highly densely populated is your storage area networks. You have high density of fibers coming onto your SAN. You will not even remove one fiber patch card from your SAN when you want to do any add moves and changes because you don't know which one you are pulling out. It's better to put on to the next port and connect it an additional and not remove the existing one. So the bend radius management is also becoming critical within your DC environment on the racks is. So people looked at in terms of, can I look at a solution of a bend insensitive on a multi-mode version of the optical fiber, which is the one which is used for your storage area networks. You look at the OM3 or the OM4. Multi-mode has many modes of flight. It has an axial mode, higher order, lower order. How do I really take care of all this? So the solution that was built was having a trench between the cladding and the core of the multi-mode, which gave a solution. Standards are expected to ratify multi-mode by Jan or Feb of 2013. Single mode is already ratified across. Look at the attenuation characteristics on a standard multi-mode of an OM4 versus bend insensitive of an OM4 is. It's almost 3.25 versus 0.32, which means when you're working on a 40 gig or a 100 gig requirement for tomorrow's, you need to build up the best of the solution in terms of looking at a bend insensitive solution within your smart connectivity of the whole city is, or with respect to the DC solution is. So OM4 has got ratified, which could support you for 4,500 megahertz kilometer across on the bandwidth is. So, and bend insensitive fiber is becoming a necessary rather than a luxury, especially for your fiber to the home solutions. Let me take a small case study. Now, there is a real estate. This is the case studies that's going on across the country today. There are a lot of installations that we have done on the gigabit passive optical network solutions, so-called the GPON solutions for your converged networks. There are multiple central offices, residential blocks, office buildings, security cameras which needs to be connected across. If you look at, there's one more number of residential apartments in the smart city was 1,376. The customer services required were voice, data, video, wireless, any applications that comes in tomorrow to managers, whether it's the water management system, sewage management system, power requirements, if anything has to be connected on an application, how do you meet these requirements are? He looked at in terms of bandwidth requirement. Today an HD TV signal which runs 15 to 20 Mbps. You look at an internal gaming of 2 Mbps, video conferencing 1 Mbps. So we looked at in terms of how do I really make it? When you have 1,000 and odd apartments, when you have central offices, when you have residential blocks, can I start laying, as I'm doing in an enterprise, every 2 core or a 6 core to each apartment, or 1 core which all falls into the DC? That's not the solution. What kind of solution that we need to look at then on a converged solution platform to support all the future applications that comes in is something called a gigabit passive optical networks that's on the GPON solution. So for one of the customers, the multiple customers have just taken one of the customers, we looked at in terms of the GPON solution. So we provided whether you want a 32 split ratio or a 64 split ratio. On a 32, minimum you can guarantee 80 Mbps to each of the residents. On a 64 split ratio, you can look at 40 Mbps at each one of the residents. I just took one of the other case study which was very similar. This was for an airport. This was the first installation on a Terminal 5 of the Heathrow Airport, where the customer was very specific in building, where he was very clear in terms of specifying 300 applications that they were running within the airport. How do I really make sure that the infrastructure built up can actually take care of all this? So he looked at in terms of CCTVs, the aerial forms, communication, display areas, building management systems, cellular, voice, data, radio services, SCADA systems for his water management. So the size of the entire site was more than 260 acres, which could give you almost around 280 football pitches that could be across. So such a kind of networks which you look at on different solutions. He was very clear that the data center has to be a tier 3 standard, which should meet across. Plug and play solution, so that any moves, acts and change, there's not much of a downtime to be operated across 24/7. There are 300 different applications that needs to run. Make sure that the distributed antenna system is built up to take care of whether it's the 3G or the 4G services across any customer walking into the city or within the airports. Value-added services, access control system, it should take care of the CCTV system, parking management system, visitor management system, campus on a Wi-Fi across, digital signages, video door phones, for a SCADA system of a water management and the power management and the sewage management across. How do you really look at all the solutions are? So GPON was the best solution to look at in terms of running. So it's an IP-based protocol and it's the choice of the media for high requirement on an FTTX carriers today, which will enable you all the different applications to drive across. How does this particular solutions work on a GPON is? Can I lay a dedicated fiber across to each one of the blocks, or point A to point B? Do I have a dedicated fibers? The answer is no. How do I connect it across on a ring topology? So you have a fiber, let's say I have a 12 core fiber dropping across. Splitting it again 1:8 or 1:64. Again taking the 1:8 and again splitting it, the same fiber, 1:4, 1:8, and making sure I drop to each one of the residential blocks, drop to each of the campuses. It looks easy. It's not as easy as we talk, because each one of them, look at in terms of the splitter power ratios. When you put a 1:2, you have an ideal loss of 3 dB. If you put a splitter of 1:16, you have 12 dB losses. So you need to make sure that the upcoming applications also meet these requirements to build up the best of the infrastructure is. There are a lot of options in front of us. You have point-to-point, which is not an option on such a large facility. Splitting in the central office. When I say central office, it's where your main OLTs are, so which gets connected across where the service provider drops in, and you connect across throughout the whole infrastructure. Centralized splitting was also not an option on a large environment, so distributed splitting was the best of the solution on such a large networks of more than 260 acres to be connected across. So, how does it actually work? Normally, most of you have seen, we lay 2 cores of fiber for your enterprise from point A to point B. One for your transmit, one for your receive. Whereas on an FTTX solution, it's one single core of fiber which actually gets dropped. It's not on 2. So you have both on an upstream and the downstream. We tested across 3 wavelengths, 1310, 1490 and 1550 nanometer. You have a different OTDR actually to test all this and make sure that the whole cable plant is fit in taking care of all the applications that run across in this campus. Just a pictorial view of on a solution of building upon a main ring, then developing across to a secondary ring across, and then connecting through the fiber to the home or fiber to the business environment within the smart city connected across. So you use splitters, you can use 1:8 and then split across each one to again is to 1:4 and then get connected across, which means I need to create zones first on any smart connectivity across. Then you need to look at sub-zones. How do I really build in these zones and then sub-zones on a large smart city requirement? So we looked at in terms of one of the solution which I talked about 3 different zones. Each one of the zones has different sub-zones. For example, one of the zone had 3 sub-zones, the second one had 7, the third zone had 4 sub-zone across to build across a distributed architecture. So we looked at one of the main admin building, then you had the LAUs, then we fit it across into 3 different zones. Each one of the zones has again sub-zones divided across with the splitters. So looked at in terms of taking care of the whole city that needs to be on the converged networks, split it across into a zone and then subdivided into different sub-zones to be connected. So making sure within a zone how the whole sub-zones are created. Then link it across each one of the zones to the sub-zones which are on a distributed architecture by dropping a fiber of each core of fiber dropping at the residential or the business requirement. This is just as the fiber lands on to a particular, let's say, an apartment within the facility, how does the fiber gets across to the ONTs at each one of the residential blocks? One of the requirement of the customer was also on a wireless on a distributed antenna system, where at any point of time, the customer should look at in terms of how do I really manage the whole solution, whether this has to meet my 2G or a 3G. But the infrastructure that you have built on the optical fiber should not change. It should meet the requirement. So we looked at a distributed antenna system which could support your data, voice, video on a mobile device, which is the most important today. Today, if you look at coverage, look at in terms of the capacity is, it has to handle all the traffic that comes in and also enable high mobile data rates that are excellent speech quality which could give and always have an access to the whole network. Foundation of the indoor applications is your wireless office and the mobile broadband is. So when you actually look at coverage, the biggest problem today is you will have coverage at some of the points and doesn't have coverage at some of the other points. So uncertainty of the coverage and unknown capacity is becoming a big issue. So you need to look at complete solution across. It's not just building an infrastructure of an optical fiber. It should also be supported with an equipment at the BTS rooms with the active devices which could take care on a distributed antenna systems. You can build it to the component at your common basement across and connect it across to each one of the residential blocks where you put across a distributed antenna systems. So at TE, we look at completely an end-to-end connectivity solution when we look at converged networks. One of the most important thing when you look at converged networks also is, we talked about managing such high bandwidth on the smart CTCs. How do I really manage? Your data center has to suffice these requirements. So which means the DC has to be highly agile, it should be available, and also the efficiency that you can build in. When I talk about the latest data centers are, look at in terms of, at TE we look at these are all highly scalable in nature. The DC that build up has to be resilient and dynamic across. So when I talk about an agility, it's all about making more quick sats and changes within your existing network. How do I really do it is something which is important. When I look at availability, there's no compromise. How do I look at in terms of reliable product portfolio? And efficiency, it's all about your CapEx and the OpEx issues. When I do an investment on my capital expenditure, how do I take care so that during my operational time, do I need to really reinvest it for any small ad moves and changes in the network? Can the existing product portfolio take care of it? That's an important issue to be addressed within your DC requirements are. So addressing as a whole, building up the best of the DC solutions for the modern environment is something which is critical. I took a very small example for a DC. This is one of them. When I go for any audits for a data center, the first thing I see is a mess around of the SAN device. You have huge fibers falling on your SAN rack. The way it looks is all about the high density of fiber cables falling onto your SAN systems. How do I really make it into the best of the systems to manage across on the SAN? Something like the one which you see at the end. How do I build in a solution which is really smart enough to take care? I'll run through a small video across here. So this will give you a I think I have a problem. This is on the storage area management.
TE brings you a high-density cable management solution that transforms data center cable clutter into an efficient, streamlined, eco-friendly network infrastructure. Storage area networks are undergoing a true metamorphosis with our SAM system. Imagine the simplicity of a system that reduces the bulkiness of cables and connectors up to 80% compared to traditional duplex fiber optic patch cords. Picture a neatly organized network that uses simple, color-coded, keyed trunk connections for lightning-fast moves, adds, and changes. Space is at a premium in your data center. With the SAM system, reduce space requirements by managing up to 512 duplex fiber ports within 2 rack units, minimizing floor space. No additional front vertical, side, or horizontal cable management devices are required. And the profile is easy to deploy in narrow cabinets or racks and limited footprint environments. Minimize cable mass and slack management using line card optimized Hydra assemblies for easy port access and unobstructed line card maintenance. Simplified scalability allows you to use pre-labeled ports, and color-coded and keyed trunk connections speed up deployment and reduce connection errors. Dedicated line card kits allow for simplified installation, upgrades, and migration. TE has a global reach as a leader in network communications infrastructure solutions. We make the products that connect and protect the flow of power and data inside the products that touch our daily lives. Our expert resources can help you plan for optimal space savings and maximum organization within your data center by incorporating products like our SAM system and more. For more information about the SAM system for simplified cable management or any TE connectivity solution, visit our website.
So today if you actually look at in terms of at your SAN, you have an MPO which is a preterminated fiber laid across from point A to the point B. So you connect it across on a fiber panel. The maximum number of fibers that a one new panel can take care is around 96 fiber, which means it's 48 duplex port. Look at how do I really manage then across within the SAN. Convert that at your SAN switch into a SAN box, which could take 512 ports in 512 duplex ports in just 2U space. So how do you really build this across? Till date, we have always looked at in terms of, I never went and asked a customer, can I build across the SAN connectivity? We just asked how many fibers do you require? We never looked at in terms of what line cards that the customer is buying, what product is he actually looking, and how do I really connect it? So the adapters can actually be looked at based on the line cards that the customer buys, and then do the labeling pattern with respect to, as per the labeling of the switches, which start from 0 to 7, 8 to 15, and so on. So you have a complete color-coded systems to manage within a 2U box of more than 512 duplex ports. That's something which is the biggest advantage of using a SAN box and having the best of the management for your storage area networks. So there is a box which takes care of more than 512. It has a guider, color-coded keyed system across to manage your entire storage area networks. Moving forward, how do I really manage a complete smart connectivity network? If a port goes down, how do I know that there is a problem with the cabling? How do I know where the problem is? What kind of solutions that I need to look at? Look at in terms of a managed connectivity solution for a smart data center management. We at TE call it as the Quario solution. Let me run through a small video on this.
What if you were able to view your entire network in real time? What if every action, move, add, or change was automatically identified and documented? What if the actions in the physical layer communicated with the upper layers of your network? Think of the possibilities and the control you'd have over your network. That time is now. TE Connectivity has developed Quario, a new connection point identification technology that brings managed connectivity to the physical layer of the network, providing unprecedented network management that had previously only been possible for layers 2 and above. From the data center to the desktop, where business continuity is an absolute necessity, Quario delivers unrivaled visibility and comprehensive reporting, enhancing network availability and security, while reducing network operating expense. Quario technology enables every connection to be uniquely identified and communicate with the rest of the network. The result is the collection of valuable network data that enables real-time monitoring, topology mapping, and problem solving from the data center all the way to the desktop. In the end, your network is more secure and available, allowing you to drive out costs and enhance service levels. It's time to really know your network.
Sure. One of the most important things is we work on something called CPID technology. It's called connection point identification, which means in your whole network, one of the component which is used for your moves, adds, and changes is your patch cables, whether it's fiber or the copper. How do I really manage it? So we looked at in terms of, that's the most important. So we built an EEPROM chip into each one of them. It has a unique ID, whether it's fiber or the copper at both the ends, which is very similar to that of a MAC ID is. So looked at in terms of managing the whole connectivity solutions and then building up an ecosystem. When I say an ecosystem, let's say you already have your work order system to manage. You're using your own, whether it's IBM Tivoli, HP Open Unicenter, XYZ, you're already managing your network across, except the physical layer. Can I link this across to the existing application that you're running and make sure that I have a single window to look at from an entire network perspective? The answer is yes, because this application of the Quario comes with an open API delivered to the customer, which can get integrated across to any of the system that you work across. Today we are working on an Aperture integration to build up. So each of these patch cables has an EEPROM chip built in, whether it's an MPO, category 6, 6A, or an optical fiber. Look at each of these panels. At TE connectivity, we don't call it as a patch panel or a jack panel. We call it as a network panel. What's the reason for it? Each of the panel, in an IDC or an ODC, if your customer wants to log in to a panel or to a server rack, it's possible today. You can actually enable each of the panel on an SNMP IP address. So, on a static IP address, so he can log into each one of the panel, which has a controller. You can put a static IP address where the customer can actually log in and see the status of each one of the port, for where it is connected across. What's the MAC ID of this particular panel? So he has a full control, including the physical layer across. When he wants to operate, sitting somewhere else, he just wants to log into his ODC and see across, whether it's an optical fiber on a backbone link or a copper on a horizontal link within your DC. There's a solution available today. You can do an open API, connect it across. You have an HP OpenView, Unicenter, Aperture, Remedy, whatever you have, you can actually connect it across and make a single window to view your entire network. One of the important topic I took is on the pathway systems, even though it's just a small picture here of both pathways. Whenever I go to any audit, the worst thing that I see is, and the best is, your network racks fantastically dressed across with colored patch cards, colored jacks. If you want to see the real mess, it's under your raised floor system. When you start opening the tails, why is it all happening? It's just because of the planning. It's just because of the wrong planning in terms of the dimension of the pathway systems. You talk about the PUE. You talk about how much of PUE I should look at. You talk about energy. You keep on increasing your energy level, but it's not helping because your cabling is actually blocking your energy system below your raised floor. So whatever you do, it's not going to improve. So it's important to have the right pathway system built with the right planning. Planning is the key for the successful infrastructure network that has to be built up, whether it's a smart city, whether it's a smart DC build up, anything that you do on an infrastructure to be built up. That's something which is the key. So you have a dedicated fiber optic pathway system separate, copper pathway system separate. It's always important to separate both copper and fiber systems entirely on a separate pathway system. That's also the recommendation of the TIA 942A. 942 is no more the standard for DC. It's 942A, which is the standard. So category 6A has been recommended. Cat 6 also is recognized. OM4 is the minimum recommended for all your upcoming DC solutions. OM3 is also recognized. So, which is why people look at pre-terminated cabling solution, whether it's a copper or fiber. It helps you to manage. It's a reusable. It helps you for quick changes. It takes care of your OpEx issues. So some of the solutions are a 10 gig product, which can take your plug and play, no termination, no testing, everything comes from the factory. It's called as an AMP Sigma link, which is compliant to 942A. Then you have an MRJ21 solutions. It's again a plug and play product, which is compliant to both 1 gig and 10 gig products available on the MRJ21. One connectivity of an MRJ21 can give you 6 ports of 1 gig or 4 ports of 10 gig. On the connectivity on the switch. There are MRJ21 switches available in the market today. It's highly reusable product. This is where you add value to the PUE. Somebody asked, what kind of value does the cabling add to a PUE? One of the important things, do the right planning for your pathway system. Don't put high density of cables flowing out of the pathway, which is blocking your energy within your cooling system. That's one of the important things. So cabling as an infrastructure might not add a high value in terms of digits, but if you don't plan properly, it will affect your PUE. So it's something which is important to take care of. So we at TE look at the dia of these cables, how much of reduced diameter of the cable can be. So it can give you an equal performance on the entire DC solutions. Is on an optical fiber, it's an MPO system. It's again a plug and play. You just take it across from your SAN to your network rack and just it's a plug and play solution built in. So today's modern data centers are highly virtualized, highly scalable and dynamic in nature. So business agility is something which is important to take care with availability and efficiency. So we have something called the micro website called datacenteragility.com. So you have a lot of white papers put there in terms of cloud computing, virtualization, how do you really look at in terms of structured cabling point of view within your DC environment and based on different requirements. We also have a micro website on managed connectivity solution called knowyournetwork.com. This is where you get an in-depth analysis of what kind of information it's available, how do I really work around on these solutions of managed connectivity. So this is a customer view. He selected TE across building such a large smart connectivity because he looked at one of the organization which could provide an end-to-end solution on data, voice, video, which could run on the complete infrastructure of any future applications that he puts in. So
this is a campus. We do have around 42 acres campus here, spread across World Trade Center, Sheraton, Korean Mall, a typical diagram what you have shown, that's simple as such. We have used OM4 with laser speed fiber, which is almost around 30 kilometers of fiber has been implemented in this technology. We thought of using triple play services like voice, video, and other services. Unfortunately, what happened is in a residential mixed enclave like this, we have to provide data, telephony, and then the television. That is voice, data, and video. What happens to the customer is he may not like to go with only the IPTV. Through the GPON solution, what we are talking about is only through the IPTV we can provide. At the same time, providing a CATV or a cable TV or a DTH services through this GPON technology is cumbersome and it is very expensive as such. So we have dropped the idea of going for a GPON at this campus for a simple reason. It was not, as a converged solution, it was not possible to deliver to the end customer. At the same time, we have used this entire campus for integrating our building management, access, surveillance, our high-speed internet connectivities, to the including the GSM connectivities. All are through a fiber with a category 6A augmented cable, which is of a high standard, and copper 10 gig on copper solution, which has been deployed. My question is, do you have a solution using OLTs and ONUs and the GPON solutions? Do you have a converged solution where I can deliver even the cable TV? At the same time, I want a DTH of a customer choice to an end customer. He may not like to go with only one single service provider. So I have to provide a multiple service providers, be it on a television, be it on a data or on a telephone services. So do you have such solution where I can look for it?
yes, the answer is yes. For example, today when you look at, this is a typical question of any customer is, I want to have my service provider that I choose. So let it come to the ONTs. So then I will choose my service provider across. So you need to set up your BTS station where all your service provider gets connected across. So when you set on an IPTV, not necessarily. You also have converters for the VDS solutions available. For example, the first project of an educational institution is across the entire campus today is IIT Kharagpur, which runs on the GPON. You talk about fiber to the home, fiber to the business, educational, each one of the blocks runs on a GPON solution. So we are working on multiple projects across. One of the project was also in the Chennai on the Hiranandani, on the close to opposite to Sirusari at Chennai. So you have completely on the GPON solution there. So you can bring in multiple service provider and connect it to this OLT. So it's not necessarily that you need to depend on one. The advantage as a customer, you become a customer for the service provider. So you're building an infrastructure across. You're building up a smart city. You're connecting across the whole campus. So the service provider, let's say you have 1,000 apartments across. Now, no service provider would like to leave it a loop there. He has got 1,000 customers there. So he is going to pay you for the infrastructure. He is going to connect it to your BTS station and going to use your complete infrastructure. The answer is yes, it's possible.
What would be the, how about this ROI in terms of investing on the GPON solution at this point in time looks to be an expensive affair as a builder. Reason being, we would like to have a private partnership like, on the OpEx model we would like to adopt. So
that is also available.
Yeah.
Today, if you look at projects that are going in this country on a smart city of converged networks, there are more than 60,000 to 70,000 homes connected already on an optical fiber on the GPON. It's not that the Airtels have invested, Bhartis or Reliance has invested. It's not that all these BSNLs have invested. The answer is no. All of us knows the problem that exists in the telecom companies today. These are the guys who have not done the investment. There's something called in between the service provider and an end customer. It's like an highway. For example, you build a highway across, building an infrastructure. I want to use that infrastructure, I pay for it. So you have an investors today. One of the investors are Velocity is one of them. He's a big investor on fiber to the home solution. He puts in the infrastructure. He works with the builders. He works across with the service providers. He charges on an OpEx model there. There are companies like Sterlite which does that across building an OpEx model of complete for the converged networks. So, thank you. Any questions?
There are no more questions, or if you want to ask offline, then
Yeah. Thank you so much.